on these together. And I know only some of you have it, but I really want your help with these, okay? So for the first one, 13, the sum of 3 consecutive integers is 78. What are the 3 integers? So I don't want the answer yet, okay? But I would love to know how you set this one up.
3 plus 3x equals 73. You want to see?
No, yes, I hear you. What is the first step to setting it up? We have to give values to all of our.
Yeah, you gotta like.
We have to give values
3 plus 3x.
because that's what it ends up
Yeah.
being. Okay, where did you get that? You just have it memorized from last time?
Yeah.
Okay, I am okay with that, but let's take it a step back. And can somebody share with me how we represent each value? Yes.
It's x.
So our first
plus
one,
and x plus 2.
so
It's
x, our second one would be
Well,
x,
it's x plus 1.
good, and our third one would be
X plus 2.
good. Now, if this problem had said 3 consecutive odd or 3 consecutive even integers, would these still be the same or would they be different? What would they be?
Even 2, 4, 6. 2 and 4.
Yes, it would be x, x plus 2, x plus 4, because we'd have to skip a number to get to the next one, right? But for now, we're going to go with this easier problem, the sum of 3 consecutive integers. So remember what consecutive integers are? 1, 2, 3, 8, 9, 10, 21, 22, 23. Something like that, all in a row. Now, the sum of all of these has to equal 78, right? Now, Callie, tell me how you got from here to then your equation that you set up.
3.
Well, what did you do to get there? How do you get from here to what you have?
You do like math.
You do math, okay.
I just have 3 because 2 plus 1 is 3.
Good, so you
And then
added
3
your 2 plus 1 together, right? Okay, so that's gonna be positive 3. All right, and what else?
There's 3x.
There's 3 x's, so we have an x 3 times, which we represent with 3x, or x 3 times. The other way, if you want to think of it this way, is you can make your invisible ones show up and then just add them together. 1x plus 1x plus 1x is 3x. So we have 3x plus 3 equals 78. If you have 3 plus 3x equals 78, totally fine. Commutative property of addition, it doesn't matter. If you do flippy floppies of these, it will give you the same answer. So now I'm going to write this over here and we're going to solve. 3x plus 3 equals 78. Can I pick on somebody else to help me through this next part? Emily, did you get this far on yours? You did? Could you help me solve it from here?
Okay.
Sure. Let's do it.
So you do minus 3.
Yeah.
And do the same thing under 78.
Yeah, minus 3 on both sides.
Yeah. That was disgusting.
Cancel. Then we have 3x left on this side. And we have,
5.
good.
And then you divide 3x by 3.
Yes.
And then do the same thing to 75.
Yes, divide by 3 on both sides, and we get x equals
25.
25. Did anybody just get 25 as their answer and just left it like that? No? That's good, because x equals 25, but they don't just want the value for x. They don't just want the first number. They want the first number, the second number, and the third number, right? They want all 3 integers. So in a row, 25, 26, and 27. Is that what you got? Good job. All right.
Next.
All right, number 14. We've got a word problem, we've got a situation. We have to break it down, figure out what's important, and how to set it up as an equation. Darren wins a coupon for $4 off the lunch special. How wonderful for Darren. How many days does he get to use this coupon? 5 days. So he gets $4 off the lunch special for each of the 5 days. He pays $75 for his 5 lunch specials. Write and solve an equation to find the original price, P, for 1 lunch special. The original price. B. You know how to set it up? Good. All right, give me just 1 second. Even though it just says write and solve an equation, you know how I like to draw my math problems, right? Especially when it's an easy thing, like it's 5 days, so I can kind of make like a box to represent the price for each day, right?
Yeah.
Okay, so I'll do it over here. I'm gonna do, this is the price, this is the price, this is the price, this is the price, and this is the price. So this represents each day that he paid. I'm gonna let these boxes represent the discount that he paid, okay? The discount. But how can we represent that discount using the original price P? Callie, could you tell me how I can represent each of these discounted lunch specials by using the original price P and the other information in here? Yes, good. The price that he pays is the original price minus $4. How many times? 5 times. Good. What's the total that he spent after using all of these discounted prices? $75. So all of these together will be $75. Right?
Yeah.
So do you agree that P minus 4 plus P minus 4 plus P minus 4 plus P minus 4 plus P minus 4 equals $75?
Yeah.
Do you also agree that years ago we learned about a special operation that makes adding the same thing over and over and over much simpler? Yes, multiplication. So instead of writing P minus 4 plus P minus 4, if it's the same thing, we just write how many times. Abby and Emily, I really want you guys paying attention, so I will bring you forward and maybe separate you if I need to, okay? If we have these lunch specials 5 times, we can write it. Callie, do you want to tell me how you set up your equation?
5 parentheses
Yeah.
minus 4
Yes.
parentheses equals 75.
Perfect. Raise your hand if you also set it up like that. Good job, good job.
Are we going to use the distributive property? No,
Sure. You can. Here's where we have the choice. Are you done?
No, I need help with the question.
Okay, can you just skip it and go to the next one? All right, so you guys might have solved this in 2 different ways. You getting this down? You are? Okay. Can you draw the pictures? This is where we have, you can use your preference. You can do the distributive property and you can do 5p minus 20 equals 75. That's totally fine. Raise your hand if you use distributive. Totally fine. And
no,
we did,
actually I didn't.
you didn't?
No.
Okay, so what did you do? You divided by 5 on both sides. That's my preferred method, but either one will work for this problem. And then we have p minus 4 equals 15. Now what do we do?
Why did you divide 15 and 5?
Why don't we?
Yeah.
15 and 5?
I just
We didn't have a 15 up here.
We had a 75.
Here, I'm gonna back up. I'm gonna write it over, okay? Okay. Here's our equation. Ask your question again.
Why didn't we divide 15 and 5?
I love your question. Tell me where you see a 15.
That's a
Oh, that's 75.
Oh.
Oh, I'm sorry.
I thought it was a 14.
Now your question makes a lot more sense.
14.
She was like, I see it right there where you wrote it. No, I just wrote a 7 in a really, really bad, sloppy way. Sorry about that.
It's like, I saw 14.
Okay. So, once again, we're going to divide by 5 on both sides to start solving for p. Now, let me ask you a question. We got p minus 4 equals 15. That's why I got confused by your question, because there was a 15 here, and I was like, well, why would we divide by 15 if we didn't even get there yet, okay? Or why would we use 15 by 5? Anyway, never mind. Good question, bad handwriting. Now, can anybody just tell me, even though this is not part of the question, can anybody tell me what 15 represents? Yes. Yeah, the discounted lunch special, right? Good. This is our discounted lunch special. But they want the original price, so we're still going to solve for p. Okay? So what do we do?
You add 4 to 15 too.
Yep.
And then we'll get 19. P equals 19.
Perfect. P equals 19. That's the original price of the lunch special, which, wow, that's expensive. $19 for, I'm sorry, the original price of, yeah, the lunch special was 19. He used $4 coupon, so he spent 15 each. The original price was 19. No, you can keep it. Totally understand? Emily, oh, do you totally understand? Okay, good. Let's go on to Olivia. Olivia ate at the same restaurant 4 times. That sounds like our family in Chick-fil-A. Right?
There's a person outside her door. She's really
It's okay. He's a legitimate person. He's allowed to be here.
What?
Hello. Oh. Okay.
Don't forget to lock the door.
Okay. Now we're talking about Miss Olivia. She ate at the same restaurant 4 times. Does anybody have a favorite restaurant that they've been to like 4 times?
McDonald's.
McDonald's. Okay,
Oh my
mine's been Chick-fil-A lately. What's yours?
Steak and shake.
Oh yeah, steak and shake. What?
Chicken tenders and tater tots from my own oven.
Oh, okay. A home restaurant. That's a lot cheaper. Yeah.
Taco Bell mixed with a KFC, and you can get a chicken.
You can get a little bit of
Yeah, you
everything.
can get a chicken taco, like a chicken burrito, and it has the KFC chicken.
Okay, that's nice. Okay, what's yours?
What?
It's a chicken.
Longhorn. Okay, that's some fancy taste. Okay.
Really?
So Olivia is loving her restaurant, so she ate there. Shh. Okay, bring it back. Olivia ate at her restaurant 4 times. Each visit, she ordered a salad and left a $1.50 tip. That seems a little cheap to me, but we'll see if it actually makes any sense. She spent a total of $54. Find the cost of each salad. Okay, let's underline our important information. Yes.
I have a question.
Yes.
So for me, I did it the same way we did the one before, but instead of like doing the tip, I just did it for all 4 days and then I made it into a number.
Okay, so you didn't set it up like an equation, you just kind of like solved it logically.
So like I just did it like the one we did before, but
Okay.
instead of 4, I did how much she did and like took it off.
Okay.
everything.
Okay, so let's see if that works out, okay? She ate at the same restaurant 4 times. So she had to pay a bill 4 times, right? Each visit, she ordered a salad and left a $1.50 tip. So do you agree that the same every time she ordered a salad, it was the same price?
No. Sometimes they can't.
Oh, that's true. Well, let's say she ordered the same salad every time,
She
okay?
ordered a Caesar salad.
Caesar salad every time. She spent a total of $54. Find the cost, C, of each salad. So C is our variable, C is what we're looking for. How can we represent this with an equation?
I mean, I told you mine.
Okay, go ahead.
Can you check it first? See for me.
Why don't you read it out? And let's see if it makes sense.
The $6 is the tip.
Bless you.
$6 is the tip. What is?
Four times.
Oh, P. So we're using C as our variable. Did anybody else have this?
Doesn't it still work? It's just a different variable. Doesn't mine still work?
Let's see.
It's just P instead of C.
So, do you agree that she spent a total of $54?
Yeah.
Okay. She went there 4 times. So it would be 4 times the cost of the salad
That's exactly how.
plus,
Plus. Oh yeah.
what would it be? The cost of the salad each time plus the $1.50 tip.
Wait, either way, I still added 24, so. Wait, I subtracted. Anybody have a calculator?
If you need a calculator, we have them here.
Wait, never mind. Wait. Give me a calculator.
So let's go over this again, guys. The total, Emily and Adam, the total is $54 that she spent. She ordered a salad, C, for the cost of the salad, 4 times, and gave a $1.50 tip 4 times. So do you see how we can represent that 4 times just by putting the cost of the salad plus $1.50 times 4? And Callie, is that what you had on? Or did you kind of distribute?
I'm just.
Okay. All right, where do we go from here? Somebody help me solve this. Go ahead, Emily.
You divide the whole equation by 4.
Yep, you can do that, or you can distribute, either one. Okay, so we have C plus 150 equals
6.
54 divided by 4.
Oh.
You need your calculator.
13.5.
What is it?
13.5.
13.5. Okay, what's the last step?
So you subtract 150 by 150, and then subtract it by 13.5.
Yep, 13.5 minus 150. Cancel, cancel, and we have C equals, C again is the cost of the salad, of each salad. And what do we have?
12.
Yep, $12. Does it make sense? What should we do to see if that cost makes sense? Check it, plug it in. So we have $12 she's spending on a salad, right? Plus a $1.50 tip. She does that 4 times, right? She visits 4 times. She gets a $12 salad and leaves a tip every single time. So that can be multiplied by 4, and let's see if we get our total, 54. And at this point, you could distribute if you wanted to, 150. Or you could just do 12 plus 150 is 1350. So far it's working, right? We have our 1350 right here. Multiply that times 4. What do you get? You get 54. So does it make sense?
Yeah.
Abby, I'd like you to move up here just because it's a lot.
She's trying to help me.
Oh, you are?
I got 850.
Okay, as long as you are laughing about math, then I'm okay.
Abby's laughing about really hiccuping all the time.
Okay. Hiccups are something we can't help. Burps, on the other hand, I won't mention any names, can be helped. Oh, you know what? Can you ask Mr. Whitman? Because he will help you.
Make sure you don't leave your head in the video. Let down.
Yeah, I'm filming this for my other classes, which we're not going over this in the classes. All right. For number 16, now we're talking about Casey. Casey bought sandwiches. Excuse me. Casey bought sandwiches and bags of chips.
So I did that math.
You did?
I got it.
Hold on. I need everybody's attention up here now because we're looking at number 16. Girls in the back? Oh, okay.
Make it all one thing.
It's okay. You can't help it, it's okay. Casey bought sandwiches and bags of chips. Each sandwich cost 3 times as much as a bag of chips. Each sandwich cost 3 times as much as a bag of chips. Let's pause there for a second, okay? And let's talk about how we can represent the sandwiches and the bags of chips. The sandwiches, we'll say S, right? The sandwiches cost 3 times as much as a bag of chips. How can we represent that? It's okay if you use another variable.
I just did.
Okay, well, let's pause here. Emily O, what do you think? If a sandwich costs 3 times the amount of a bag of chips, how can we represent that? And it's okay if you use the variable C for a bag of chips. A sandwich is, or costs, 3 times as much as a bag of chips. You can use C for the bag of chips. You need some help? Okay. Emily A.
So I have a question
Okay.
on 15.
Okay.
What you do to like the 12 times 1 point,
I did 12 plus, when I plugged it back in, I did 12 plus 150.
4 times?
And then I multiplied it times 4.
Okay.
Draw. That's what I would start with. Okay.
Are you guys ready to go on to 16?
This is good.
Yes.
P,
You know what it is. Okay, good. But you know me by now. I'm not interested in the answer. I'm interested in how we get the answer. You want to help me?
this
So,
whole thing is
how can we represent the sandwich cost?
This part, P is equal.
S.
Times.
Right, we're going to represent the sandwich cost with S. How can we represent the sandwich cost using the variable C? Yes.
Using a variable C.
Yeah. It says a sandwich costs 3 times as much as a bag of chips.
So write it down and what do you do?
What times 3? C times 3. So 3C. Okay? That's just kind of mapping out what the information that it's giving us so far. She bought 5 sandwiches for $6 each and spent $42. That's our total. $42. She bought 5 sandwiches, So I'm gonna write 5 sandwiches. And,
Thank you.
and it says that the sandwiches are $6 each. So now we have, our sandwich cost is $6. 5 sandwiches for $6 each. And spent $42. How many bags of chips did she buy? Okay, so if she bought 5 sandwiches, 5 times what? What's the cost of a sandwich? 6, right? So 5 sandwiches is $30 plus the cost plus some bags of chips, right?
Chips cost $2.
That's not bad. Like 10 out of 13.
I've been drinking water. Leave me alone.
Yes.
I got a 76.
What are we doing? Are we doing the chips or the sandwich?
We are trying to find out how many bags of chips. Oh, they want to represent that with B? Okay.
Just like,
Yeah.
I got a 76.
Okay, but with the extra credit, it'll be.
76. Yeah, I did.
No, I know,
he
but
did
I-
it, and he did it out of 13.
Oh, okay. Okay, that's good. That's good.
Thank you, Mr.
Yeah, no problem. What's your name?
Zachary.
Zachary. No problem.
Thank you, that's actually very helpful. Because I've got mostly algebra and then 1 geometry in here.
Gotcha.
All right, guys.
He locked the door because he doesn't know.
Yes. Okay, so let's map this out again, okay? I'm gonna start over here. It says that sandwiches are $6, and we also know that sandwiches cost 3 times the amount of chips, which is, they want to represent it in B. I'm going to represent it with C because I don't understand why you would say, oh, bags of chips. Okay, 3B for bags of chips.
Did we already solve the
Oh wait,
chips?
but that would be the cost. Hold up. That would be the cost. Yes.
Did we already solve the chips? What did
Not
we
yet.
do?
Let's back up. Oh, Ricky, we don't know, okay? Okay, so if she spent a total of $42, and we know that she spent $30 on sandwiches, because the 5 sandwiches are $6 each, right? And she spent some amount of money on bags of chips. She bought sandwiches and bags of chips. Each sandwich costs 3 times as much as a bag of chips. So if we know the price of sandwiches, do we know the price of the chips? Yes.
Can I tell you what I did first?
First, to answer that question, if we know the price of sandwiches, can we figure out the price of the chips?
Yeah, I know what the price is.
Yeah, go ahead, tell me.
So basically,
Wait, would you tell me the price first? $2. Good.
I
So we know that the price of the chips equals $2. So how can we set this up? $30 plus what? Just wait a minute.
plus $12 in chips.
How did you, no. We don't know how many bags she bought yet though. Because it has how many bags. We're representing bags with B.
Oh, the
So
fee.
$30, what? But we're talking about prices. The price of the sandwiches plus the price of the total price of the chips would be what? We know that each bag costs $2, but we don't know, whoops, how many bags, right? That's supposed to be a B. We know that each bag costs $2. Did anybody set up the equation like this?
I
30
set it up
plus-
in my head, which I did the math.
Okay, let's see if your answer is correct, okay? $30 plus the total price of the bags of chips equals $42.
Give her a pat on the back.
Subtract 30 on both sides.
That is definitely not good.
And then we get 2 times the bag of chips. How many bags of chips equals
12.
12.
5, 6, 10.
Divide by 2 on both sides. Did you get it right?
Yes.
Good.
And I literally just wrote on my paper 6 times 5, 30, and 3 divided by 6 equals 3.
Yeah, so these are simpler ones. That's what this is from lesson 1. These are simpler ones that you can kind of solve logically, and that's okay. But we also, the whole point of this lesson was to be able to write an equation to represent the situation, because it's going to get more complicated.
We turn this
So
in.
the number of bags would be 6. You don't have to turn it in.
I think you would enjoy having this.
So you guys did not have to do number 17, okay?
We had to do each piece.
Which is actually really simple, so.
It's free 99.
Okay. What?
It's free 99.
$3.99.
Free.
Free 99.
So free.
That is not okay.
Yes.
It's free 99. You don't have to pay for it. It's free 99.
Okay. All right, let's jump down to number 18 here.
It asked me property use.
Yeah, we don't have to solve anything, right? What property was used on this equation to obtain this equation? Distributed. Did everybody get that one?
Yeah, it's
Yeah,
pretty easy.
because they distributed this guy to both of the terms in here, and that's all they did. They didn't even solve it.
You just got me confused on number 15. That's all.
I got you confused on number what?
I finished it. I figured it out.
You figured it out without me?
With this.
You can keep it.
It's not homework.
It was homework.
Past tense.
It's not.
It was due today.
So I don't turn it in.
Why do you have to turn in every homework? Why isn't it just satisfaction enough just to do it?
You